back. Today we're going to talk about square and cube roots. First of all, let's talk about square roots. You may have seen these before, but square roots have to do with multiplication of a number where we're multiplying the same number by itself. So in math terms, it says the square root of a positive number p. So some number p could be 8, could be 16, could be 9, could be anything. So the square root of a number p is x if x squared equals p. So for example, what we're saying is this. If I've got 3 squared, which is equal to 9, okay? So 3 squared meaning 3 times 3 equals 9. And then I say something like x squared equals 9. So I know that x equals 3. See how that works? Okay, so square meaning you're using it as a term twice. Where this comes from is, let me draw you a square. And so if I'm going to find the area of this square, and I say it's 2 by 2, the area equals 4, or 2 times 2. Well, square root, meaning if I have a box and the area is 9, and I know that x is one side and x is also the other side, well, what two numbers are going to multiply together to get me 9? So I know that the area equals x times x, which is 9 is the area, because that's the area, equals x times x. Oops. 9 equals x times x. Well, the square root, which is shown by the symbol of 9, is equal to the square root of x squared. 3 equals x. Okay, so that's the nature of the square root. It means it will be the size of a square, the two things that are multiplied together to get you that number. The principal square root has to do with the reality, because really I could say the sides of this box would be 3 or negative 3, because negative 3 squared also equals 9. But the principal square root is the positive square root. So the positive one is the principal square root. Perfect squares are numbers that have integers as the square roots. So, for example, 1, 4, 9, 16, 25, 36, etc. Because 1 is 1 times 1. 4 is 2 times 2. 9 is 3 times 3. So you see how I'm multiplying integers together to get those numbers? So you can go on and on to these perfect squares. So what's a cube root? A cube root of a positive number p is x if x to the third equals p. For example, 2 to the third power equals 2 times 2 times 2 equals 8. So the cube root, written as a square root with a 3, would be what number goes as a factor 3 times? This cube root of 8 is equal to 2. So remember that 3 up top says I'm using it as a factor 3 times. So let's look at these equations. We've got 4 equations here that we're going to try to solve. X squared equals 121. So I know that that means x times x equals 121. Well, knowing our math facts, we're going to say what number multiplies times itself to get 121. Well, I know it's more than 10 because 10 times 10 equals 100. So it must be more than 10. So I'm going to try 11. And sure enough, 11 times 11 equals 121. So the square root of x squared equals the square root of 121, so x equals 11. What about if we have a fraction here? A fraction here, we're going to solve it the same way. I am going to take the square root, because the square root undoes squaring, so the square root undoes the squaring. So on this side, I'm left with x, and when I have a fraction, really, I'm taking the square root of top, or numerator, and the square root of bottom. And I'm going to make that a fraction. So I'm going to say the square root of 16 over the square root of 169. And so x is going to be equal to, well, the square root of 16 would be 4, because 4 times 4 is 16. And the square root of 169 is 13. So x is 4 over 13. What about these cubes? Okay, so for cubes, I know that I'm using it as a factor 3 times. So if I don't know what this is, I'm going to say, let's rewrite here. So x to the third equals 27. So I'll take the cube root, denoted by that little 3. There's also a quartic root, the 4 root and the 5 root, the 6 root, all that kind of stuff. So the cube root of x cubed is x. And I need something here. Well, let's think. 2 times 2 would be 4, times 2 would be 8. So we know it's more than 2. So what about 3? 3 times 3 is 9. 9 times 3 would be, 27. Okay, so the cube root of 27 is actually 3. Let's try this one. When I'm taking the cube root, got to do the same thing to both sides. Same rules still apply. Same thing to both sides. The cube root of x to the cubed, x to the third, would be x. And I'm going to take the cube root of the top and the cube root of the bottom. Well, the cube root of 8, I remember, is 2. And what about 125? Well, I know it ends in a 5, so its factors could be 5s. Is it 5? 5 times 5 would be 25, times 5 would be 125. So my cube root of 125 is 5. Okay, so this is 2/5 here. I want you to try these ones down here on your own, and we're going to talk about those in class. Thanks for watching, guys, and we'll see you next time.